In the last video, we introduced one of our first laws of light, which is the law of reflection. And the law of reflection is sometimes called the bouncing law of light because it sort of tells us how light behaves when it bounces off an object. So as I drew in the last video here, there can be some object here which can just be about anything. It doesn't have to be a mirror or something shiny. It could be anything at all. When light comes in like this, the question then is, well, what does light do when it bounces off this object? Does it go straight back on itself? No. Does it go straight up on itself? No. Does it go, say, straight to the right? No. Does it go back to the left? No. On all of the green arrows, those aren't the right directions. Light always is going to take a very symmetrical bounce like that, so that if you have your normal line drawn in here, which is a line that's perpendicular to the surface of interaction, then this angle right here, which is called theta 1, is going to be equal to theta 2, that angle in there. That's the way light always bounces off a surface. So again, if you have a surface like this and you have light coming in like this, and you draw the normal in there, which is that line that's perpendicular to the surface, you won't see this. Okay, that's not going to happen. You won't see this. That's not going to happen. You won't see something like in between like that. You have to be very, very careful and only pick that one line. Let's see if it's coming in like this, that hits and goes out exactly symmetrical like that. You always have to be able to look at the law of light, the reflection, and say, did that ingoing angle, whatever I chose, does that exactly equal this outgoing angle? So this is the right path, but light would not do that, would not do that, and would not do that. Only one of the paths is the right one, where the ingoing angle is equal to the outgoing angle. I'd like to show you a few examples of that here. Let me just scroll down here. I'll show you that in just a second. I'll show you this in a minute here. Here we go. Here is an example of an actual laser beam being sent through water that's bouncing off the surface of the water, as I told you here, illustrating the law of reflection. So the water is going to be right down here, and what they're showing here is this laser beam, which is just a great approximation for a light ray. And I'd love to show you laser beams in the actual class, but of course we're not there for this experience. But you just imagine this laser beam that you can see here going in this direction, just the way I described. There it goes like that. And right here at this point is where it bounces off the surface of the water, and it doesn't go out this way, or doesn't go out that way, or doesn't go back on itself. It always reflects off to exactly make those angles equal. So this is an actual laser beam coming in and out, so I can sort of draw, the arrows of the light ray going in like that. And if I wanted to put the normal on, that normal would be something like right here. And you can tell that even for that laser beam then, here is the theta 1 and there is the theta 2, and they are equal. Now, what you can do sort of as the person in charge here, or what light can do out there in astronomy and stuff, is it can vary the ingoing angle. Okay, that is something you can control. The outgoing angle light controls, but the ingoing one you can certainly control. So if I scroll up just a little bit, here's another example of the same laser beam hitting the same water right here. And you can tell it's going to go down like this once again and go back up again. But it does so in such a way that it always maintains those angles being equal. So I can just barely squeeze the normal in like that. And if I do that, you can tell that that angle right there would be your theta 1, and that angle right there would be your theta 2. And once again, theta 1 is equal to theta 2 here. That's the law of reflection. And theta 1 is equal to theta 2 here. That's the law of reflection also. So let me show you another example of this, just so you can get a good visual grasp of this here. Is I have a simulation running here that shows you over here, you see this where my mouse cursor is. This is sort of a simulated laser beam that I can turn on and off. You see I have it on right now. And again, laser beams are just great approximations for light rays because they're straight and narrow and all that sort of thing. So I can turn it on and off. And what the light ray is doing is it's coming down the direction of the mouse cursor right here. And here it's hitting something called, let me drag the slide over maybe to water there. It's hitting something called water, sort of light blue water, hitting right there. So what does it do? Well, the brightest ray you see actually goes down. We're going to talk about that law in a minute. Just ignore that for the moment. But the law of reflection you can see is very well dictated in here. Here's the laser beam coming down, and there it goes up in the law of reflection like that. And you can see as I move the laser beam around, that law of reflection is always maintained, right? In other words, what you should be looking at here is see how this angle in here, which is my theta 1, how is that dictate what theta 2 is, which is this angle over here. So you can tell that they're always equal no matter what I do. There's a very steep ingoing angle right there, but theta 1 is equal to theta 2. Here's a normal line right there. It even says normal down here on the checkbox, so I can turn that normal on and off if I want, but it's a useful guide for sure. And I can go all the way down here like this and see very gradual angles like that, we'll see. But no matter what, this angle is always equal to that angle, and that is the law of reflection.